Hello everyone, welcome to today's lesson on compound events. Up until this point, we have been just finding probabilities and possible outcomes for a single event, like just rolling a cube or picking a tile. But now we're going to look at compound events. So it might be rolling a cube and picking a tile, or spinning a spinner and flipping a coin. Okay, so quick definition for us to talk about is a sample space. So a sample space is the set of all possible outcomes of one or more events. So the sample space of flipping a coin is heads or tails. The sample space of rolling a number cube is 1, 2, 3, 4, 5, and 6. And what we're going to do is look at two or more events, and to do that, we're going to create a tree diagram or create a table. I'm going to show both of those to you, and there's some advantages and disadvantages to either one that I will talk about. So let's jump right into an example of a compound event. All right, so here we're at a sub shop, and we can choose ham, turkey, or roast beef for the meat, and either wheat or pumpernickel for the bread. So let's just say you randomly choose a meat and bread, and we want to find out the sample space. So what we want to find out is, what are all the possible sub sandwiches that we could possibly get? Well, let's go ahead and start with a meat. So for the meat, and I'm going to abbreviate, for ham I'm going to use H, we could have a ham. Turkey, I'm going to use T for turkey. We could have ham, turkey, or roast beef, I'm going to use R. All right, next I get to choose a bread. So for ham, I can have that on wheat, or I can have ham on pumpernickel. I can have turkey on wheat, or turkey on pumpernickel, and I can have roast beef on wheat and roast beef on pumpernickel. So my final outcomes, which is my sample space, I would have, well, let me just write in, I would have ham for those, turkey for these, roast beef for these options. What I'm doing is I'm following the tree. So I'm going ham, ham, turkey, turkey, roast beef, roast beef. So now ham on wheat is one option, or ham on pumpernickel is my second option. Turkey on wheat, turkey on pumpernickel, roast beef on wheat, roast beef on pumpernickel. So this is my sample space, and there are possible outcomes of 6. So I have 6 possible sub sandwiches that I can make. So that's building a tree, and trees work nicely when there's not a lot of individual items, and it also works well if there's 3 or more events. So let's look at a table and how that would work. So for a table, you'd set up your meats as the rows and your bread as the columns. So if you had 2 things, make one the rows, one the columns, and then go ahead and fill in the table. And it works out pretty easily. So here are my rows for ham, turkey, well, what happened there? Turkey, roast beef, and now I fill in my bread. So ham on wheat, ham on pumpernickel, turkey on wheat, turkey on pumpernickel, roast beef on wheat, roast beef on pumpernickel. So that's a table is a nice clean way to do it. A nice and organized way. The downside of a table is that once you get a third event, so if you were able to choose a snack to go with this, there's really no place to do that. You would need a cube, a 3-dimensional cube, to be able to do that, and it gets a little tricky. All right, but again, it does work nicely for 2 events, and again, as we saw with the tree, there are 6 subs possible. Now what I want you to notice is this 6 is in relation to how many of each possible outcomes there are for each of the events. Notice there's 3 possible meats, 2 possible breads, 3 times 2 is 6. All right, so I'm going to have you go ahead and try one of these on your own. Well, actually, let's talk probability next. All right, so what is the probability of not choosing ham and choosing wheat bread? So I just copied the tree from our previous slide. So here's our tree, and we want to know what is the probability of not choosing, so not equal to ham, and choosing wheat bread. So what you can do, and you could do this with your table as well, you can identify how many of these options, possible outcomes, make this true. Well, we know we don't want ham, so it's either turkey or roast beef, and we only want wheat. So turkey on wheat, roast beef on wheat. So that gives us 2 sub-options that make this true. So 2 favorable outcomes out of the 6 possible, which is 1/3. So the probability is 1/3. All right, now it's time for you to try it on your own. And you're going to look at some pizzas. So if you randomly choose a crust and a style of pizza, first define the sample space. You could use a tree or table. Then how many different pizzas are possible? You can use these abbreviations if you want. Might make things a little easier. So go ahead and try that. So I made a tree, and here are the different possibilities. A total of 8 possible pizzas. Notice again, there are 2 crusts. There are 4 styles of pizza. 2 times 4 is 8 possible. Now let's try a probability. So again, I just copied this tree from the previous slide. We want to know the probability of choosing a stuffed crust pizza that is not veggie. So you want to identify out of these 8 pizzas, how many are stuffed crust that are not veggie. Write it as a probability. All right, so if we're going for stuffed crust, we're down on this branch of the tree, and we have not veggie are Hawaiian, Mexican, and pepperoni, so there are 3 out of 8 possible. All right, so very good. Let's go ahead and now look at what we call the fundamental counting principle. And I've already mentioned this in that all you have to do is multiply the number of possible outcomes for each event, and that will tell you the total number of outcomes for one event followed by the next event. Okay, so you just multiply those together. So if it was M was the different crusts, N was the styles, there were 2 crusts. 2 crusts times 4 styles would be 8 possible outcomes. And this works if you have 3 events, 4 events. As long as you have a series of events that happen in order, then you can just multiply those items together, those number of events together, and you will find the total possible outcomes. All right, so a couple of quick examples, and then we'll do a couple probabilities. So find the total number of possible outcomes of spinning the spinner and rolling a number cube. So for the spinner on the left, how many possible outcomes are there? There are 4 possible outcomes. And then we can multiply that by how many possible outcomes are there for the cube? There are 6 possible outcomes for the cube. So if we multiply those together, we get 24 possible outcomes for the compound event. Okay, so if we built a tree or a table, we'd end up with 24 different possibilities. All right, now if we look at the next example, this one we have 3 events happening. We have spinning the spinner, rolling a cube, and flipping the coin. Again, all we need to do is multiply the possibilities for each event, and we will get the total possible outcomes for all 3. So we know that a spinner has 4 possible outcomes, and then we multiply that by the cube, which has 5 possible outcomes, or 6 possible outcomes. And then finally, the coin has 2 possible outcomes. So if we multiply all those together, we have a total of 48 possible outcomes for these 3 events happening sequentially. Now we can use this same principle to determine possible outcomes when we're talking about probability. So let's look at a probability problem. So if we can multiply the outcomes together to find the total number of outcomes, we can multiply the probabilities together to find the probability of a sequence of events happening in order. Okay, so what is the probability of rolling a number greater than 4 and flipping tails? Well, let's go ahead and find each probability. So the probability of rolling a number greater than 4, well, we know we can do a 5 and a 6. So that's 2 numbers are greater than 4 over 6 possible, which is simplified to 1/3. And then the probability of flipping tails is obviously 1/2. So if we want to find the probability of first rolling a number greater than 4 and flipping tails, all we need to do is multiply the 2 probabilities together, similar to how we would multiply the number of possible events for each event. So it's a very similar concept. And this is going to be a lot easier than having to create a sample space with all of the possible outcomes and then counting. So we have 1/3 for rolling a number greater than 4. We have 1/2 for flipping tails. So altogether, 1/3 times 1/2 is a 1/6 probability of rolling a number greater than 4 and flipping tails. All right, chance for you to do one on your own. So what's the probability of rolling at most 4, so 4 or less, and flipping heads? All right, so I'll give that one a try. So probability of rolling at most 4 is 2/3. Probability of flipping heads is 1/2. Multiply those and you get the probability of both of them happening is 1/3. All right, that'll do it for our lesson on compound events.